Today we are going to be solving absolute value inequalities. In order to solve absolute value inequalities, you are going to use the following notations. So you're going to look at your problem and figure out if it's less than or equal to, greater than or equal to, and then you're going to use the equivalent form to solve the inequality, as well as graph the solution. And we know that if it's just less than or greater than, you're going to have open circles, and if it's greater than or equal to or less than or equal to, you will have closed circles. We also know that AND statements are a range in between two numbers, and OR statements are values, two values that both cannot be true at the same time. To solve these problems, we're going to need to look at the chart that I just showed you guys. So for this one is the greater than or equal to. So for that, the solution is going to be AX plus B is less than or equal to negative C, or AX plus B is greater than or equal to C. So I'm going to plug this in. My AX plus B is the part inside the inequality. So I have 3x minus 7 is less than or equal to, and the C is the value to the right of your inequality symbol. So it's going to be negative 5. Or 3x minus 7 is greater than or equal to 5. So I'm going to go ahead and solve this. I'm going to add 7 to both sides. Then I have 3x is less than or equal to 2, and I go ahead and divide both sides by 3, so x is less than or equal to 2/3. Or, I'm going to solve the other part, so I'm going to add 7 to both sides. So I have 3x is greater than or equal to 12. Divide both sides by 3, so x is greater than or equal to 4. I need to go ahead and graph this on a number line. So I have my number line, -1, 0, 1, 2, 3, and 4. Since these are less than or equal to or greater than or equal to, I'm going to have closed circles. So I'm going to have a closed circle at 2/3, which will be in between 1 and 2, 0 and 1, I'm sorry. And I'm going to have a closed circle at 4. And I'm going to go ahead and shade accordingly. I need numbers less than 2/3, so that will be shaded to the left. And I'm going to need numbers greater than 4, which will be shaded to the right. So my solutions are x is less than or equal to 2/3, or x is greater than or equal to 4. For the next example, we have the absolute value of 2x plus 1 is less than 9. If I look at the chart that I showed you guys in the beginning, we're going to use negative C is less than AX plus B, which is less than C. C is, in this case, it is 9, so I'm going to have negative 9 is less than 2x plus 1, because that's the stuff inside the inequality, which is less than 9. I'm going to go ahead and solve this. So I'm going to subtract 1 from both sides. So I have negative 9 minus 1 is a negative 10 is less than 2x, which is less than 8, because 9 minus 1 gives us 8. Once again, I need to get the x by itself, so I'm going to divide both sides by 2. So I have negative 5 is less than x, which is less than 4. I need to finish this by graphing this on the number line. So I have negative 5, I'm going to do 0 and 4. And I need numbers in between negative 5 and 4. And because these are just less than signs, I'm going to have open circles at negative 5 and negative 4. And I'm going to shade in between. This would be considered an AND statement because it's a range in between negative 5 and 4. Just a reminder, if you have anything added to or multiplied to your absolute value, you have to go ahead and get rid of that before solving any problems. Thanks, and I'll see you guys tomorrow.